Welcome to the first lecture on graph theory. My name is Dr. Soumen Maity. I am faculty at Indian Institute of Science, Education and Research, Pune. I am grateful to IISER Pune and NPTEL IIT Madras for giving me this opportunity to work on this project. This course graph theory is divided into 7 modules, and in the first module we will talk about basic definitions. So, this basic definitions will include Eulerian graph, Hamiltonian graph, bipartite graph, complete graph, trees and many more. And then next we talk about minimum spanning trees, and here we talk about Prim's and Kruskal algorithm to find minimum spanning tree in a weighted graph. Third, we talk about matching, and we learn how to find maximum matching in bipartite graph. In the fourth module, we learn what is vertex cover and edge cover and also independent set. In the fifth module, we learn what is connectivity. We talk about vertex connectivity of a graph and edge connectivity of a graph, and how vertex connectivity and edge connectivity are related. Next, we talk about network flows, and in this module we learn how to find maximum flow in a given network using Ford-Fulkerson algorithm. Also, we learn what is minimum cut, and we will prove that the maximum flow is equal to the minimum cut. And finally, we talk about planar graphs and graph coloring. So, we talk about vertex coloring, edge coloring and coloring planar graphs. So, the reference for this course is Introduction to Graph Theory by D.B. West, and the second reference is Graph Theory by R. Diestel. Let me start with the definition of graph. So, a graph is a pair VE of sets satisfying E is a subset of V cross V. Here V is the set of vertices and E is the set of edges. And a graph G prime, which is having the vertex set V prime and E prime, is called a subgraph of graph G if V prime is a subset of V and E prime is a subset of E. So, let me give an example of a graph. So, these are the vertices of the graph and I call them V 1, V 2, V 3, V 4, V 5 and an edge joins two vertices. So, this edge I call E 1 which joins V 1 and V 2. This is another edge which joins V 1 and V 2. I call it E 2. So, the edge E 7 joins V 1 and V 5. E 3 joins V 2 V 3. E 5 joins V 5 and V 3 and E 4 joins V 3 V 4 and E 6 joins V 5 to V 5. Okay, so, this is a graph G with vertex set V 1, V 2, V 3, V 4, V 5 and the edge set consists of E 1, E 2 up to E 7. If there is an edge joining V I and V j, then they are adjacent. So, here you can see that V 2 and V 3 are adjacent because they are joined by an edge E 3, whereas V 2 and V 5 are not adjacent. Otherwise, they are non-adjacent. Two or more edges with the same endpoint are called parallel edges. And a graph is simple if it has no loops or parallel edges. So, for example, here E 1 and E 2 are parallel edges, and E6. So, E6 is a loop. E6 is a loop, whereas E1 and E2 they are parallel edges because they have the same endpoints. So, next we talk about complete graph. A graph is complete if every pair of vertices are adjacent. So, for example, this is a complete graph with one vertex, that is called k 1. So, this is a complete graph with two vertices, this is denoted by k 2. This is a complete graph with three vertices, this is called k 3. So, this is a complete graph with four vertices, is k 4. So, a complete graph with n vertices is denoted by k n. So, definitely the number of edges of a complete graph with n vertices is n choose 2, because if there are n vertices, then every pair of vertices are joined by an edge. So, there will be n choose 2 pairs and n choose 2 edges. Next, a graph is finite if both the number of vertices, this is the cardinality of V, and cardinality of E are finite. And a graph is infinite if cardinality of V or cardinality of E is infinite. Okay. So, we understand a special type of graph now, that is called complete graph, and Kn is denoted, is the notation for complete graph with n vertices. Now, next we learn what is degree of a vertex. Definition: the degree of a vertex V in a graph G denoted by dV is the number of edges of G incident to V. Okay. So, let me give an example of a graph. So, I label this these vertices by V1, V2, V3, V4, and there is a loop here. So, here you can see that the degree of V3 is equal to 2, because 2 edges are incident to V3. Degree of V4 is also 2, because there are 2 edges incident to V4. Degree of V2 is equal to 3, because there are 3 edges incident to V2, and the degree of V1 is also 3, because this will be counted 2 degree plus 1 degree here. A graph G is said to be K regular if the degree of V is equal to K for all vertices V belongs to K. Okay. So, an example of a regular graph. This is called C4, cycle of length 4, you will learn soon. So, here you can see that the degree of every vertex is 2. So, this is 2 regular graph. Okay. And one observation, that a complete graph on n vertices is n minus 1 regular So, this is because a complete graph with n vertices, every vertex is adjacent to all the remaining n minus 1 vertices. So, every vertex is having degree n minus 1. So, a complete graph with n vertices is n minus 1 regular. Next, we talk about a theorem. If a graph G with E edges has vertices V 1, V 2, V n, then the degree sum, degree of the vertex V I equal to 1 to n is equal to twice the number of edges. So, E stands for the number of edges and n stands for the number of vertices. So, in our previous example, if I see that here the degree sum, there are 4 vertices. So, the degree sum is summation of d of V I from 1 to 4 is equal to 10, and this graph has 5 edges. So, E equal to 5. So, this degree sum is equal to twice of E, right. So, it is a easy observation because the proof is that every edge contributes to in the degree sum, right. That is why this is the degree sum is equal to n. So, you can see here that this edge, for example, this is contributing 2 degree in the degree sum. So, 1 degree is counted as degree of V 4, degree of V 4 is 2 because of this edge and this edge, and the degree of V 3 is also 2 because of this edge and this edge. So, this edge is contributing 2 in the degree sum, that is why the degree sum is twice the number of edges. Now, we denote something called maximum degree. So, this notation that delta of G is equal to the maximum degree. So, we will use this notation several times, and the maximum degree here is 3. So, this is 3 here, and small delta G is the notation for minimum degree, and the minimum degree here is 2, right. Now, corollary of this theorem, in a graph G, the average degree is twice E by n, because this is the degree sum and there are n vertices. So, that is average degree of every vertex is twice E by n, and obviously this average degree twice E by n, it will be smaller than the maximum degree, and this will be the average degree will be greater than the minimum degree of the graph G. Okay, so these are all fine. Next, we talk about another theorem. This says that in any graph G, the number of vertices with odd degree is even. So, if I draw this graph again, now this vertex has degree 2, this vertex has degree 2, this vertex has degree 3, this vertex has degree 3. Now, you can see that the number of vertices having odd degree is 2, and that is always true. Why this is true? Here is the proof of this. Let B 1, B 2 and B n be vertices of G, and for simplicity, suppose V 1, V 2 up to B t, they are odd vertices, and V t plus 1, V t plus 2 up to V n are even vertices. The meaning of this one is that odd vertices means the vertices with odd degree, even vertices means the vertices with even degrees. So, these are the even vertices, these are the odd vertices. Now, what we know is that we know that the degree of V 1 plus the degree of V 2 plus the degree of V t plus the degree of V t plus 1 plus the degree of V n, that is the degree sum is equal to twice E, right. Now, what we can do is that I can write degree of V 1 plus degree of V t, these are the odd vertices, equal to twice E minus degree of V t plus 1 plus degree of V n. Now, this is 2 E is even, and these are all even vertices. So, this is also even. So, this is even. So, the whole thing, the right hand side is even, right. The whole thing is even minus even. So, it is even. Now, we know that this each term here they are odd, because this is the odd degree. So, the left hand side this will be even only if the number of terms is even. So, here degree of V 1, degree of V 2, degree of V t are all odd, but their sum is even. The sum is even. So, t must be even, and the t is the number of odd vertices. So, what we have proved is that if in any graph the number of vertices with odd degrees is even. So, in the first part of first lecture we have learned some basic definitions like degree of vertex and some related results. In the second part we will learn what is walk, trail, connected graph, complement of a graph and many more. Thank you very much.